Let's talk about one of the most important upgrades happening to our world right now, and it's one you probably haven't even noticed. It's called post-quantum cryptography. Think of it as a silent, invisible revolution happening in the background, all to protect us from a threat that isn't even fully here yet.
So let me ask you a question. Are your digital secrets, your messages, your bank info, everything safe forever? You probably assume they are, right? Well, the real answer is getting complicated. And that's exactly why this quiet upgrade is so incredibly important.
Okay, to really get why this matters, first we need to understand the security we all depend on every single day. The best way to think about it is as a kind of digital fortress. Every single time you send a message, check your bank balance, or just browse online, your private information is locked down tight inside this huge fortress. And the walls of that fortress are made of encryption. It's the technology that keeps your private life private. So what are the bricks and mortar of this fortress? Well, it's all built on top of really, really hard math problems. Problems that are just too difficult for today's computers to solve. Take integer factorization, for example. It's like this. I give you a massive number, and you have to figure out which two prime numbers multiplied to create it. For a regular computer, cracking that would take literally billions of years. That difficulty, that's the bedrock of our security. But here's the thing. There's a new kind of computer on the horizon, one that plays by a totally different set of rules. And that brings us to the big challenge, the quantum countdown. And here's the threat. It's an algorithm called Shor's algorithm. You can think of it as the ultimate skeleton key, one that only works in a powerful quantum computer. A math problem that would take a normal supercomputer longer than the age of the universe to solve, a quantum computer running Shor's could in theory solve it in minutes. And there's a name for that future moment, the day a quantum computer is finally powerful enough to break all of our current encryption. Experts call it Q-Day. It's the moment our digital fortress could basically crumble. Okay, but here's the really scary part. The threat isn't some far-off future problem. It's a risk right now. It's because of a strategy called harvest now, decrypt later. Right now, adversaries are sucking up and storing huge amounts of our encrypted data. They're just stockpiling it, waiting. The plan is simple. Wait for Q-Day to arrive, and then use a quantum computer to unlock everything. A secret you send today could be read by someone else years from now. All right, so that sounds pretty bad, right? But don't worry, the good guys, the cryptographers, are already on it, which brings us to the solution, a whole new breed of code. All over the world, scientists are in a race against the clock. Their mission? To invent a completely new generation of encryption. The idea is to build a new kind of fortress based on totally different kinds of math that even a super powerful quantum computer won't be able to solve. And what's cool is they're not just designing one new type of wall, they're inventing whole new architectural styles for this fortress. You've got things like lattice-based cryptography, which is kind of like hiding a secret inside a super complex, multidimensional grid of points. Then there's hash-based, code-based, and a bunch of other brilliant approaches. Each one is built on a different class of math problem that we think will be tough even for quantum computers. So you have all these brilliant new ideas floating around. How in the world does everyone agree on which one to use? How do you pick the new global standard? Well, let's meet the quantum-proof champions. To figure it out, the U.S. National Institute of Standards and Technology, everyone just calls them NIST, kicked off this massive, multi-year global competition. Seriously, think of it like the cryptography Olympics. Teams from all over submitted their best algorithms, and for years, they were all intensely tested, attacked, and analyzed to see which ones were the strongest. And in 2024, after all that brutal testing, they finally announced the first gold medalists. For general encryption, just locking and unlocking your data, the new champion is an algorithm called CRYSTALS-Kyber. And for digital signatures, which prove who you are online, the winners are CRYSTALS-Dilithium and Sphinx Plus. These are the new foundations for our digital future. But there is a catch. This new super strong security comes with a trade-off: size. A typical key in today's encryption is tiny, like 32 bytes. But a new key using CRYSTALS-Dilithium, it's over 1,300 bytes. That's a huge jump. We're talking more than 40 times larger, which is a real challenge when you think about things like internet speeds and data storage. Okay, so that leads to the final big question. How do you actually upgrade the entire internet to these new, much larger security standards without, breaking everything?
The answer is actually really, really smart. It's a method called hybrid encryption. Think of it as a belt and suspenders approach. Instead of just flipping a switch, you use both the old and the new systems at the same time. So your data gets encrypted once with a trusted classic algorithm, and then it gets encrypted again with one of the new post-quantum algorithms. To break in, an attacker has to defeat both. It gives us the best of both worlds, today's proven security plus tomorrow's protection.
And get this isn't just some theory for the future. It's happening right now. Apple is rolling out a new post-quantum protocol called PQ3 to protect iMessage. Google is already testing this stuff in its Chrome browser and on its security keys. And the Signal messaging app has already upgraded its system. This silent upgrade is already protecting millions of us. So what's the big takeaway here? The thing to remember is that we are in the middle of a monumental preventative upgrade to our entire digital world. It's one of the biggest cybersecurity shifts in history, and it's all happening quietly in the background to keep us safe from a future that's rushing toward us. We are literally building the cryptographic fortress of tomorrow, designed to withstand attacks that we can only just begin to imagine. And that kind of leaves you with a final thought, doesn't it? As technology keeps leaping forward, what new, unforeseen threat will the architects of the next fortress have to defend against?